All right, good morning, guys. Thank you so much for coming to our first annual Engineering Showcase at Bellville High School. We are so thankful that you're here. A couple of little housekeeping things. I know they showed you around, but if you would put your phones on silent so we don't have interruptions during the presentations, I would appreciate it. We also have, other than our amazing students who are going to introduce themselves as they come up and present, we also have a panel of judges who have been so helpful throughout the years. They've made donations, they have come in and helped and gave our students advice, critiqued presentations that they've done throughout. Just been amazing in giving of their time. So I'm gonna let them introduce themselves and tell you a little bit about them, and then we'll get started with the presentations. Kevin, would you like to start us off?
Sure. I'm Kevin Meckler, hardware engineer at Cisco.
Jared Huddleston, mechanical engineering manager at Wood, energy, oil and gas here in Houston.
Grant Lishka, I'm a civil engineer that has my own business here in Bellville.
My name is Zach Brown. I'm a mechanical engineer. I'm an engineering project manager, so energy, oil, and gas as well.
I'm Zane Rhodes, president of New Point Gas, and so we work together.
Okay, we have one more judge who will probably be sneaking in a little bit. He was coming all the way from Dallas, so he may have hit traffic, I don't know. But you may show up in a little bit, Marcus Benavides, and so he'll be here as well. We're gonna go ahead and get started because I know it's a lot of presentations today, and thank you guys very much for judging and helping us come up with. We're gonna have awards after, so we'll do 3 presentations, a short break, then we'll have 2 presentations. They are presenters. We'll actually lunch with our engineering panel, and the culinary, our high school culinary class has provided that for us. And then our junior high culinary class actually provided the snacks. So I'm so appreciative of everyone who has helped out. Our high school AV crew is kindly videoing and recording this so we can show it to future aspiring engineers as they come up through the program. So much help has gone into this to make it happen, and I'm so appreciative of everyone. All right, without anything else, I'm gonna hand it over to the stars of our show, the students.
Okay.
All right, hello. First of all, thank you guys for coming and good morning, and thank you for supporting our engineering project and everyone who's been working throughout the year to get this done. My name is Alex Flores.
My name is Drew Morrow.
And we are here to present you the Trek Tech Tactical Staff, also known as the Trek Tech TS.
All right, so as very experienced hikers, me and Alex have found a variety of problems when it comes to hiking, and because of this, we have created the problem statement. This problem statement is what has guided us through our process of creating the Trek Tech TS and is what we are ultimately trying to solve with our product. Around 75% of outdoor enthusiasts face challenges related to gear management inefficiencies and safety hazards in various settings, according to the Wilderness Education Association. This is across many different settings like hiking trails, remote wilderness areas, and adventure expedition locations. According to a 2022 study by Montana State University, 67% of backpackers experienced gear malfunction or loss during their trips, with 15% of these people experiencing injuries due to improper gear selection or setup. This is an issue that is pervasive across all different environments, all levels of hikers, and all around the world, which is why we are trying to solve this problem with our product. So our response to the problem statement is to lighten the load of backpacks and to make an easy carrying of hiking essentials. And the way that we are doing this, the way that we are lightening the loads of hikers to mitigate some of the challenges that I was just talking about, we are doing weight redistribution. When we are taking the weight out of the backpack and into the Trek Tech TS.
With that said, let's get into the Trek Tech TS and actually what it's made of. So the Trek Tech Tactical Staff is made up of 4 to 5 compartments consisting of a flashlight compartment at the very top, which my colleague will demonstrate. It has a flashlight in the middle that easily pops out that you can turn on and then put back into the Trek Tech TS whenever you're using it or wherever you need to put it away on your hiking trip. It has 4 compartments consisting of ranges between 7, 6, 5, and 4-inch compartments that you can stick your needs in, ranging from snacks to easy necessities that you may need on your hiking trip. And what we want to stress is that the Trek Tech TS is not necessarily replacing the backpack and what you're going to put inside of it. It is a mitigation of weight distribution so that you can put whatever you need inside your Trek Tech tactical staff on easy hiking trips and make it accessible for all hikers. In that bottom compartment, the 7-inch compartment, we also have a life straw.
It's in there. Just trust. There's a live straw right in there.
Sorry about that. The PVC kind of locks up. But we have a live straw in there that the hikers can easily use and put inside the water that can get rid of bacteria so that they can safely drink water on their hiking trips whenever they're in danger, whenever they need hydration. We also have at the bottom of the staff, we have a short little pole that's used for stability. And at the very bottom, we have a 3D printed piece that can easily grab onto the dirt or whatever ground you are walking on to ensure efficiency. And to get into the compartment, just a little inside look, we have our PVC about 2-inch pieces. We have our male compartment and our female compartment. And then we also have a little wood stopper on the middle to prevent items within the compartment of actually falling out. And I'm going to pass this to the judges so y'all can get a closer look at the compartments.
And then as y'all look at this, just one more thing I want to emphasize is that our final product, this is just a prototype due to unavailability of materials, but our final product will be made out of carbon fiber, and this will allow for the product to be very lightweight, and it'll also solve any issues like we just had with the locking up of the PVC. That will not be an issue when our product is made out of carbon fiber in its final form.
Mm-hmm.
All right, so this product is going to run you $250, and you may think that this is a very expensive product just to go on a hike, but this is actually a very justified amount when you consider that this is a premium product that will be solving a lot of major issues. When backpacking with more than 15 pounds, there are many statistics that show that that is a very negative and poor thing to do on your hike. There is an 11% for performance impairment. There's a 7% reduction in aerobic capacity and a 0.7 degrees Celsius increase in core temperature. By creating this hiking staff, we were able to mitigate those issues, and this is something that is worth the $250 price tag that we have put on it. I also want to make everyone aware that when you are buying a premium hiking product, if you were to go into a hiking store, it is very rare to come out with a product less than $200, $300, $400. This is marketed towards people who are very serious about hiking. It is a product that is made out of the highest quality materials that will solve a very major issue. So some of the past solutions before the Trek Tech TS, there were a variety of things that people did to carry their stuff on their hike. We have things like a mule cart or carrying in your hands. And in many circumstances, people use a quality hiking backpack, which can run them over $100. And once again, the issue that we've described with backpacks like this is that it causes a lot of weight management and temperature inefficiencies, which once more is why our product is better than all of the past solutions.
So to make sure that the Trek Tech Tactical Staff or the Trek Tech TS was the most compatible and the most efficient in the market of hiking, we wanted to look at the market competitors. And the two major competitors that we found were the outdoor tactical walking stick from Prime Adventure, running you about $95, and the hiking stick collapsible walking stick staff from Ioto, which runs you about $35. As you can see, they're similar designs, multiple compartments that combine into one staff that have multiple different fittings. While doing the research, we found actually a lot of drawbacks from our market competitors, and we can break this down in 4 major sections. One of the first ones was heavy weights. We found that a bunch of these products were actually weighing upwards of 8, 9, 10 pounds that can be really, really inefficient when you're walking around and actually add to those statistics that we were talking about with the reduction in aerobic capacity and performance impairments. We also have limited scope. Most of the designs that you just saw, they have very similar designs. They have the easy compartments, and then they have the fittings on the end. And basically, when you want to look at the broader picture, there's limited scope in terms of carrying your needs around where you need them the most and being efficient on your hiking trip. Limited space, you can see here, there's not much space that you can actually fit in there. And usually it's just normal metal bars that you can fit little fittings on there like knives and screwdrivers, etc. And with the Trek Tech TS, we want to make sure that you can be efficient as possible and fit your needs and your items inside the Trek Tech Tactical Staff wherever you're walking around. And then also we found that these products also had poor durability. On much of the customer reviews, there are many reviews of scafing and damaging, benting, and just a bunch of different damage that's happening to these staffs and these products when you're out in the hiking environment. With the Trek Tech TS that will eventually be made out of carbon fiber and durable materials, we want to make sure that we stray away from those market competitors so that we can surpass them and be as efficient as possible with our product.
All right, so in creating the product, we had a lot of design considerations. This was a long process, and as many of you know, this engineering class is a year-long capstone course. So in this course, we went through many different variations of the Trek Tech TS before finally landing on the design that you have today. I just want to highlight a few of the major ideas that we had in the past. All right, so our first main idea that we had was to target the elderly market and allow them to go on hikes and solve the gear inefficiencies that we talked about today. And with that, we had the idea of the hiking walker. The hiking walker could hold many essentials, and it is very good for the elderly market. You know, they could hike along with their walker, and they could go on all the trails that they want. But ultimately, we decided that this does not have enough scope, and this isn't a large enough market, and we're not solving a huge issue by creating an elderly hiking walker. Furthermore, you know, when we got closer to the design that we have today, we had a compartmentalized staff, but the major difference was that it had a cane handle, as you can see here. This cane handle would be a more ergonomic design and allow people to have potentially more comfort in holding the staff, but the issue with this is that it wouldn't be able to hold a flashlight. Putting a flashlight inside of a curved compartment would be very impractical and not something that we could put together. So we ultimately decided to have the final version, the final concept of the Trek Tech TS, as you see here, that has been designed to meet the very specific needs of experienced and amateur hikers. The size, the aesthetics, and the capacity are all honed in and designed to make the perfect product for hikers, and safety is paramount in this product. It provides safety essentials and ultimately is the best product that we could create to solve the problem statement and the issues that we have described today.
And I want to touch on one more thing that Drew did not mention in our final concept. So a bunch of this walker and this caned hiking staff, they don't have adjustability in their heights. You're kind of set at one height. With the Trek Tech TS, we want to make sure that we can apply to as much audience as we can, ranging from people who are 5 foot tall to people who are 6'5" tall, and all the heights in between. And by doing that and by adding that extra compartment that's down there, we want to make sure that we can apply to as much audience as possible, and with interchangeable parts and different things you can use to make the staff as compatible with you and your preferences. So going into prototype construction, we started this actually about a month or two ago in starting the staff. And basically we used a bunch of PVC, the parts that I told you about, and we went across the school going to multiple classes, multiple construction classes, and we took trips to various local hardware stores like Ace Hardware and other places around Bellville and Brahmas to make sure that the Trek Tech TS was as compatible and efficient in its prototype design. It was a very long process, and it took a lot of hard work to do, but we eventually got our prototype together, and it's as it is here today. So prototype testing. We want to make sure that the prototype of the Trek Tech TS was as efficient as possible and as compatible as possible so that we can develop it into something great and grand in our final product. And we want to scale this down to 4 major testings. We want to make sure that it had a good performance in its operating environment. We took it around Drew's house and around my house, and we walked around with it out in our pastures, out in our lawns, to make sure that the Trek Tech TS can be used efficiently and has great compatibility when you're walking around, to make sure that it's not scafing or benting or anything like that. Oh, can we restart that?
Yeah. This could go all the way back.
Yeah, it's fine. Sorry about that. Okay, our second test was load management. So we want to make sure that the Trek Tech TS is able to withstand about 250 pounds of force, because as you're walking on it, ranging from people who are 100 pounds to people who are heavier than that, we want to make sure that the Trek Tech is compatible and durable so it doesn't break on impact and you're not going to be damaged or be put in danger, which is the thing that we're trying to prevent in this whole process. We also want to test the bowing resistance. So we're going to put the Trek test between 2 surfaces, kind of like this right here. We're going to hang weight in the middle to make sure that whenever you, again, playing into that idea, when you plant down on it and you're walking, you want to make sure that the Trek Tech does not bend, and then making it as safe as possible. And then durability, simply, we just want to make sure that our product is durable and that it doesn't get damaged upon impact when you're using it in that outside environment. So we're just going to do drop tests, and we'll
having the gear that you're bringing on your hike in your arm instead of on your back.
Can y'all share a little bit about how you came to the $250, whether that's the material cost or market.
Yeah, so the average hiking staff or pair of hiking poles comes to be about $100 to $200. That's like the mid-range for a good quality hiking pole that you could get at a standard hiking store. And we believe that using the premium materials is clearly going to be a little bit more expensive in creating our product. And this $250 range was created, or price estimate was created by researching the amount that carbon fiber costs to manufacture, as well as looking at other manufacturers of other hiking sticks and seeing about how much it costs them to create their products.
Any other questions? Any from the audience?
I know y'all referenced and said that y'all had a 3D printed tip for your staff. What material is it made out of?
Whatever was in the 3D printer when it started.
Whatever was in a 3D printer at the time, so.
So, I'm Kyle Middleton. I'm Sammy Bradshaw, and this is the Charge Lift. So, the reason we made this product is, I'm sure you're all aware, during the COVID times, the traveling ban was in, and a lot of people weren't allowed to travel due to the simple idea of infection and people getting sick, all that sort of stuff. And so once the traveling ban stopped and it came down, people started traveling again, and like a big boom too. So when that exploded during 2020, clothes chargers often forgot their phone chargers at home. That was just an apparent thing, and that's things that people do. So around 1,000 travelers surveyed, or about in 2012, 24% forgot their things at home. Now applied to a world population, that's around 1 billion to 2 billion people. So we decided that we should target that 2 billion people and find a way to prevent that from happening.
So when thinking about the problem, we came up with 3 main topics, and our first one was forgetfulness, as you just heard. With low battery life in the U.S. consumer is a major stress point, with 44% saying they're regularly bothered by it. So with forgetting your charger at home, you're already stressed out during your trip. Second is availability. We're wanting to target availability with being able to charge anywhere, anytime, and anything. Through any conditions, you can wear it. As you'll see here in the next one, for part 3, it should be worn for diversity, and we wanted to have multiple parts, so you can charge anything, as you heard, and it should be able to be durable through all types of weather.
All right, and so to find out the numbers about this survey, we find out about this problem, we ended up taking about 4 surveys. So question 1 being, do you often forget your charger at home when you're traveling? That was a simple yes or no question. As you can see, out of the 25 people, a lot of people said yes. It's a apparent problem, and this even in people at school. Question 2 was, do you often need to charge your phone? That was just for the more popular people that ended up using their phone more often during the day, even while traveling. Applied to a big population. As you can see, a lot of people even more said yes. And then for a different approach to these 3 questions, we ended up having questions 3 and 4 on the second picture. This was, how often do you wear jewelry? Now, we ended up targeting this question to both men and women, and I'm happy to say we ended up doing a good 13 to 12 split of comparison of men to women. So instead of just asking a lady, hey, how often do you wear your necklace? How often do you wear your ring? How often do you wear a watch for a man? Stuff like that. And as you can see, a lot of people said yes. In question 4, this was more of a quality of life kind of thing. How often would you say that, or if you have ever gotten one, if you've ever gotten a skin irritation from wearing said jewelry? And out of a lot of people that said yes, we've ended up finding that cheap metals and very irritant materials, and like rough leather, stuff like rope, unbristled chains, stuff like that, it ends up causing a lot of skin irritations.
So the charging market is obviously pretty big. There's multiple chargers out there, all types, and so these are some of the most ones that we were most related to with current and past solutions. Obviously, you have Apple, one of the biggest markets out there right now, with their new MagSafe, which includes a magnetic component to charge to the back of an Apple iPhone. You have lightning cables, you have USB-Cs. Then you have the Samario bracelet, which is a wearable charger, but it's bulky and has limited charging options with the USB to lightning. Then you have the static 360 magnetic phone charger. It implements a magnetic end on one side, so you can change out multiple to anything you want to charge. And then you have the Ascend and Paracable, which is a normal charger, but Ascend has multiple charging options that you see up here, and then Paracable has durable and more limited options.
So these are the several of the ideas that we had to run through before settling on a final idea. So we had our design one. This was the pendant. You would essentially lose the actual flip those pictures like that picture over there. You would essentially lose the actual cord option that we were going to present to you, but instead you gain a very small, about as big as an AirTag, about around that big, that you could keep on your person. It would give you about 4 hours of charge, and you could fully charge your phone in a matter of 30 minutes. And you could keep it on the go, one charge, one and done, and you're back on your day. Now, design 2 was the elongated control. This was essentially a normal charger that you would find and that you'd bring on a traveling, that you charge your phone in at home, yay big versus yay big. And that was simply to model an idea off the Paracable design. And design 3, this was our coup de grace. This was the magnetic and special attachment. And as you can see, once we get into it, a lot of people chose the magnetic over the standard pendant idea. So the magnetic and the interchangeable ends, this was the 3 ideas we wanted to target. The connection, USB to USB-C to micro to USB to lightning, all of that. We wanted to have an ability to interchange from USB to USB, USB to USB-C, USB-C to USB lightning, stuff like that. And as the USB-C is hitting the market more with Apple doing their new adaption thing, they're switching from their normal to the USB-C that's most common in most electronics. Versatility, the interchangeable ports. We wanted that kind of availability, and also there to be wearable. We wanted it to be able to fit around the wrist, fit around the neck, fit around, I don't know, if you're an anklet guy, you never know, if you feel like doing that. And number 3, that was the cord. We wanted it to be durable, comfortable, and aesthetically pleasing. We didn't want you to be walking around with it looked like a big piece of wire around your neck. We didn't want you to walk around with a very bland looking piece of black material.
And so throughout our testing phases, which you'll learn about later, we figured out that the magnets wouldn't work. So we implemented a 3D printed design on our charger. And so this was our first design. It implemented a little section where the wires would connect, and this piece that would hold the ports would slide down in, and when you twisted it, it would allow the connection to run through the charger. And then when you're not wearing it, the other end would have another end like this that would just go in and slip in, and then you would be wearing it.
It was you slide in, twist, and you can start your charger.
And then the design 2, which is what we have over there on our thing, implemented a bigger hole because we wanted to have on our ports, which you'll learn about on the next slide, you can like leave it in your phone if you wanted to, so you don't have to worry about losing it or such things. And same thing here, it's made out of rubbery material. You slide it right in, and the connection is allowing to flow through, and you can charge your phone. And so this was the port housing, or we call it the PH. So this was our first design. It just implemented the thing the ports going right in, and then we'd have a little knob right here on the outside for the twisting mechanism. But then we decided that wasn't gonna work, and so we made a design 2, which we implemented the claw system. So on the outside, it has the 2 little knobs, and we have a spring in the middle, so it allows it to grab onto these little holes that you see here, allowing for the connection to the ports. And then when you're wearing it, it just unlatches and connects it to the holes on this part, and allows you to wear it, and you can move it around, and it allows for your charger to move. So you want to set your phone up this way, it can bend because the little holes allow it to rotate. So
it's a 360-degree movement on this kind of panel.
Yeah, and it prevents like fraying and such damage to the cord.
So for the prototype construction, we had this kind of 5-step program that we needed to accomplish chronologically just to get where we wanted to be. So step 1, attach the male ports. That was the interchangeability that we needed to offer from like the USB to USB-C, all that sort of stuff. And not to mention that was probably the most difficult part, resizing, sizing everything again, finding out we did something too small, one more time, back to throw everything away one more time. And step 2 was make up the cord. We needed to actually be able to make a phone charger. That was something that we could compare to Apple, to Paracable, Ascend, all the other products. Step 3, attach the cord attachment to the cord. That was the implementation of the claw, implementation of the housing system that we need to create. Something that could take the power that we needed from an outlet and put it into the adapter that we had. Attached forward, this was the claw, the actual claw. This is what we use to house the other porting options that we can use to interchange. Step 5 was construct something to hold the extra ports. So we realized that more often than not, you're not going to buy USB-C if you don't need it, right? You're not going to buy USB if you don't need it. You're not going to buy Lightning if you don't need it. So in case that something like that happened, we were going to create a small little container, bag, something that you could keep on your person, keep it home so you wouldn't forget. Probably not on your person, but that if you needed to interchange it, you could leave it there, you could leave it at home, but you couldn't forget it where you put it.
And then, so this was our testing throughout. We first tested our solder strength. We wanted to make sure that when we soldered, it would be able to withstand the yanking and usage that a normal cord would, especially if it's like a kid using it. Sometimes kids don't have proper and they just yank the cord. So we wanted, and it did pass, so that was good. And then we had our magnet strength. This was part of our first design. We wanted to see if when we soldered to a magnet, if it would keep its magnetism, and obviously that failed. And so we had to rechange the entire design. So then next we wanted to test for durability. We wanted to make sure our product can withstand weather, environments, constant usage, and strain. And that obviously passed. And then the charging aspect, our prototype, while it can't charge, we connected to the main points on our charging. We wanted to make sure that it could, so we attached cords to each major knob on our prototype, and it did charge. But the prototype itself, with one of the cord attachment piece, wasn't able to allow the other piece to go all the way down because we had wires. So because of the limited technology we had and time, we couldn't get that exact part done. But it does charge when you connect it to the major points. And then this was material. We wanted to test material for the comfortability and aesthetic part of our design later down the line, but we didn't get that far in the process. But yeah, that will be tested. We wanted to make sure that the material we choose is aesthetic and comfortable and durable. So, and thank you for sitting here and coming, and good luck.
Any questions?
Do you have the prototype?
Oh yeah, it's over there. Yeah, we forgot to bring it over here, but.
You're better at explaining it. There you are.
So you can pass these around. These were our prototypes. We had to use glue since we didn't have dry materials. So we had to split up our prototype. We have a line down all of the things because we had to get the wires in the middle for the connection to get through. So all of them are split in half, which is obviously a big design problem, but we would, in our final design, make it out of a metal so the current would allow it to go through easier and we could wrap it in the rubber linings. So this is the claw, as you can see here. If I stick it right here, it'll allow it to go through. And so it holds, you can wear it. And this is 3 times, we made it 3 times our wrist length, so it's a good necklace length and your wrist length. And then when you're ready, you take one of those, you shove it in here, and it allows the connection to go through. If you want to look at that.
So you need a special connector on each end.
Mm-hmm. And then this also connects to those green pieces. We wanted to make that multiple, so when that connects to that, it allows the current to go through as well. So essentially that is the same as the cord attachment, it's just in a different form.
How hard was it to get the current to go through different types of connectors?
Oh, it is pretty hard. We realized that USB and USB-C, you have to actually switch the cords to the different on different sections. So ground would be on this side, and the red wire would be on positive would be on this side, and on USB it switches. So positive would be on this side, and ground would be on that side.
It was a couple days of panic, to be honest. When we figured out that you didn't know how to do that.
The claw actually broke several times. If you go over there's actually 2 of them that are actually broken. So we had to print the claw out like 5 or 6 times, and then the rubber piece was actually PLA first. It was a hard material, and we soon realized that wouldn't work because it didn't provide the flexibility that one does or allow it to go in.
GPU?
Yeah.
Can these be put in backwards?
I don't think so. It has to, we were gonna label it, but we didn't get that far because it wasn't it didn't work. So it's like, why label it? But
So what prevents it from going from you put
so
positive and the negative to the
if you look on the inside of the cord attachment when you get to it, since our design, like since the technology we had for 3D printing, we couldn't get the wires to go through and up, so we had to go inside the cord, and so that we didn't calculate for that, and so it actually lifts up the green pieces, and it doesn't allow for the connection to go through. So if you stick in one of the green pieces into the cord attachment, it'll pop up like very so slightly, and it just doesn't allow the connection to go through.
very hard to do this, that's the reason. Injection molding and all that makes it a lot easier than us, it's great. Thank you.
You had a question?
Did y'all break the front? You went flipping the coin?
His phone was just
It was not called. So we originally settled HBC was the it's on the market right now. It's one of the most versatile. It's, as I told you before, it's Apple's starting to adapt it as well. Samsung, Android, they all use it. Most Chromebooks use it. However, Chromebooks didn't give you an alert when it started charging. So my phone was the only thing we had on standby that would give you an actual notification saying, yeah, you're charging now. And we figured it out halfway through that it was working and we were happy.
Great.
No breaking yet. Nothing yet.
Audience, any questions?
Where'd you get the connectors from for the?
We bought them off Amazon. We looked out individual female ports and then, or not female, male ports, and then okay. Actually, the USB-C we had to modify slightly. It came with like a little compartment that you flip up, and so you can solder it in and you can close it. We actually had to cut that part off and keep the 2 prongs.
It was a fun couple hours cutting. So.
Yeah. And also, did you look into like what percentage of new devices on the market have USB-C versus micro USB?
We didn't get that far, but we know the market. We know the money of the market. It's around a $20 billion market, and around 10% or like half of that is wire charging. And I would assume that since Apple's starting to adapt it, and that majority of items that you see are maybe your computer's a USB-C too. Majority electronics take a USB-C, so I'm pretty sure it's a big market for the USB-C.
Is there a goal for it to actually transmit data as well, or charge?
Not right now at the moment. It's just trying to get a wearable charger so people don't forget and have to go buy chargers. So
The data cord, that was an option at the very beginning. However, we could never find like the LAN cables that we needed to thin enough that would be able to fit properly with the kind of wire that we already chose to use. We ended up panicking like day 3 because we couldn't figure out why it would not transfer data. Then we realized that we needed the LAN cable to go with it as well. And so we just kind of gave up on that for now, but we've always had the idea in the back of our minds to somehow implement that and be able to use it overall. Any other questions from the audience as well? Yes.
For future reference, do you have any other ideas for design? Something made out of leather or?
Well, I'll take this one because this is on the top of my head already. So the idea of the surrounding material, such as the plastic that we passed around, that's just the plain old wire that you give. And then there's the kind that you have at home. It's the kind of woven, what's the word for that? Paracord? Paracord. Woven paracord. It's that. But then there's some options where it's, again, just plastic like you would see. Could you go back a couple slides to the ASUS and that comparison real quick? This one right here. So paracable, static, them, that's the woven paracord. And we figured out we could adopt that later on. And then there's stuff like the normal plastic. You could easily color that if for like the aesthetic option. Maybe if you give like a marker in color, you could do that too if you felt like it. But the multicolored like ASUS, we're not that extravagant. We don't have those kind of colors on standby yet. Does that answer your question at all?
What about implementing something like a scenario?
Like the leather?
Yeah, the leather, yes. that is an option. However, we don't have leather. We gotta get leather. It's the only problem. Yes.
So I had a question. So you were saying you had to expose the terminals on the outside, right, in order to get the wires to go onto them. The terminals, I haven't seen your thing. Are the terminals like actually still exposed?
No, they're he knows a bit better, but they're
On what part? The
actual terminals onto the
like the port holders? Or
on.
these ones?
Yeah, like where the wires are actually.
Yeah. So on those, we didn't have the wires all the way trimmed down because we wanted to make them exposed so we could test the charging as on our test. But on the like final prototype, it won't be exposed because the claw has to be able to get in. So with so it wouldn't be exposed and it would just be more protected and just allow for easier connection.
Can you go back to the earlier design that had the push and twist?
Oh yeah.
this one.
Okay. Can you, now that we've seen like the prototypes, can you tell us what happened or why didn't you go that direction?
So when we implemented so it could fit, we realized that they're all different sizes, all like the ports. So each one would have to be a different size, meaning the cord attachment would have to change in diameter on each one. So that was a problem we had a problem with. And then this part, it's just too long. We realized that that's just huge, so big, like it stuck out a lot. Plus the cord attachment, it was like pretty big.
You end up having about a block the size of your knuckle sticking up the top of your head, and that's not very comfortable at all.
That was just like a rough design. We were like, this would be a good idea to just twist and it would allow the connection, but we soon realized that it also wasn't gonna work. So
half the reason we scrapped it is because we were working with such small materials in front of you that the inside lines, the little nubs that would come out, they wouldn't print sometimes. You'd be missing them because the printer just couldn't make something that small and that specific of a cut into the shape. Very small. Any questions?
yes.
So one thing is that if you ever let R2 test these USB-Cs to your device, wouldn't there be like a chance of it having like it be stuck in it with this charger?
There shouldn't be. Like as long as you don't like bend the port itself, it should go in and out really easily. I mean, we could test one if you wanted to.
Are you offering your phone? But the idea of the port itself is supposed to be, could you go forward like 2 so you can see the housing? The idea of this is that there's going to be no room to bend. It holds the entirety of it, and the portion that's not in your phone is encased in this. Anything that would bend is in the claw. That's all.
And then we wanted to, like, so you wouldn't forget anything, like all those small pieces, obviously you might think that's going to be hard to keep up with. We wanted to make sure you could leave it in your phone, so it's small enough to leave in your phone so it didn't bother you, didn't affect anything, and when you're ready to charge, all you have to do is push it on your phone and it starts charging. And then just take out whatever end you need for the other end. But
how do you charge the charger?
you just plug it into a power source. So another question that was asked earlier in the year was, is it gonna come with a cube or is it gonna come with a power bank? We realized that you can probably go walk around anywhere and there'll be a port of USB or USB-C anywhere, like a computer. You can plug it into a computer, you can plug it into a car. There's wall outlets now that have USB. So we realized that you don't really need a cube to use this thing. So.
Thank you.
Well, thank you again, judges, for coming. My name is Zach Lushner.
I'm Wagner Volkel. I'm Zach Bradshaw.
And we're here to present you a project that we came up with to basically help with cooling down during the hot summer heat. So in 2020, we found that roughly 20,000 cases of heat-related injuries happened over the course of the year, which is roughly 18% of athletes like football players, cross-country players, people that are out in the heat. So we decided to find a solution to this project, and because of all this heating up, we found lots of problems like heat stroke and the padding inside your helmets to heat up quickly, shoes getting hot, stuff like that. Like your just body is heating up constantly. All this can cause lightheadedness, nausea, exhaustion, and even elevated heart rates. So we found that southern U.S. states are the most impacted, like Florida, Texas, Louisiana, stuff like that. And that was our main target market, was those southern states, because it gets so hot. One thing we found was it can even get up to 105 degrees inside the football helmet, which is a major safety concern. And we wanted to find a way to fix that issue without compromising the safety of the helmet. So in 2020, a study was conducted by the University of North Carolina, and the indirect mortality rate, such as heat stroke, heart attacks, have surpassed the fatality from direct traumatic injuries 3-to-1 since 1990, which is a major problem and shows that football helmets have gotten safer, but we aren't getting any cooler. So we conducted some surveys and found that through the group we asked them, have you worked outside in the heat? Most people would obviously say yes. And we asked them, did you ever feel overheated during that time? And 75% said yes, which is a big problem. So then we asked them, how many products do you know help cool you or athletes off when you're outside working in the heat? And they said that, or 72% of them said that they know under 10 products that can help them out. So some of those products were like the Tiger Air helmet, which is something that was made by the LSU athletics, that basically has fans that can blow air on you to help cool down the athletes when they're playing. The only problem with those was that can be expensive with fans, electronics, and with sweating comes the water from your sweat causing water and electricity not really mix very well. Other products being the hotspot detector, which doesn't exactly cool you down, but it has a sensor inside the helmet that alerts you when you're starting to get too hot and need a break, whatnot. Other cooling products include the Frog Tog, which is a very common item that everyone I'm sure has used before. It's made of materials that easily cool down, and you normally put it around your neck or in your hat. Another one was the neck fan, which is battery-powered fan that blows air on you, and you have to recharge this, which can be an issue. Again, water and electronics do not normally mix very well, so if you start getting sweaty, it can cause problems. The last one being the ice vest, which you put a bunch of ice packs in the vest. That can cause weight issues and, can be uncomfortable. So we decided to... So we decided to look into what those products are made with, and you can see this was the neck fan, that was the Tiger Air, that was the heat sensor. We didn't want to copy these products because they were already patented, so we had to find our own solutions. But a lot of the criteria, which Wagner will explain, came into effect.
So the first criteria is the durability and safety, and obviously for a helmet, definitely want it to be durable and safe. No safety means obviously there's going to be legal action against us. Size and weight, more weight is going to be uncomfortable, and obviously don't want it to be too big or else it's going to be uncomfortable. Cooling down and lifespan, well, the main goal of the product is for it to be cool you down, so we definitely want it to do that. Lifespan is how long it's going to last until something more new comes out. Definitely wanted it to last a while, so we keep selling our product and keep it working.
So the elements, we wanted to withstand every element ideally, but this is mainly for cooling, and it's mostly southern states that are cool, so it has to be able to deal with the heat. Other elements would be ideal, but we've mainly focused on the heat aspect of it and the dryness aspect of it. Comfortable in cost. If it's cost too much, school's not going to want to buy it, no matter how much it could do for their athletes. Schools are cheap, and if it's comfortable with the athletes, I'm not going to stand up here and lie to you. If it's not comfortable, an athlete's not going to want to wear it, no matter how much it does for them. Like if it's scratched or if it's itchy, you're going to have to scratch during the game, and that's a distraction, which we don't want that. Reusable materials and aesthetics. So if it's not reusable, that's a one-time thing. It's not going to be worth buying. It's not going to be worth making. Materials, we had to make do with what we had. So it's not what a final product would be, but we got it done. And aesthetics, completely irrelevant because it would be inside a helmet or a hat. That's you.
All right, so decision matrix, we're going for the sweat cap, the battery fan, and the water sprayer. Obviously, we went for the sweat cap, battery fan.
Water and electronics don't mix well, as we all know. And the battery, that's the wrong one. The battery fan, it's already been out. Water sprayer, water and electronics don't mix well. Water gets on electronics, it's fried, it's not gonna work. The sweat, okay.
All right, so this is one of our first ideas. The water sprayer, it'd be like a mechanism that you put inside the helmet and you'd like push a button to spray it. Pros, it'd definitely be effective, but cons, it'd like cost a lot and it would be hard because water and electricity don't mix. All right, so in the middle of designing our product, we decided to change gears because at first we started off going for football helmets, but then we realized that definitely wouldn't be feasible and we'd like to go to a broader market. So we went for all helmets, and in time, we hope that we're going to get a football helmet and have our product work for that. So our second idea was the headband. Pros, kind of simple to make and definitely work. The ice packs would be in these little pouches and you'd snap them onto these little snap buttons. It'd be adjustable. Main problem that we had with this one, and it kept riding up and we really couldn't solve that. So we went to our next solution.
So one more thing. We had this first one, which worked okay, but it wasn't tight enough to actually like stay very well. So if you're like lean over, it would fall off. So then our second design there, we tried to add more elastic bands, but like Wagner said, it would keep riding up on you. And we just kind of had to scrap this idea because we had too many complications with it.
All right, so the one we definitely went with right now, the ice cap, you'd have like this little structure full of bags and you'd put the ice bags in there and it'd go into the helmet. Pros, kind of simple, definitely easy to make.
You want to show them where you're going to take it off and let them see?
So you can see that.
Oh, very chilly. So this was our test. As you can see, the first one was temperature in the head and in the bags, and we had Wagner here with the helmet on after it was cooled by a not very good freezer, so the ice packs weren't as cold as they could get. But we had him do 4 50-yard jogs every 5 minutes to get him sweaty, to get him sweaty, to get him working, so we could really feel it. No, we ended up losing 27 degrees in the temperature of his head, and it gained 8 degrees in the bags. And then this was how long the popped and unpopped bags, how fast they would get cold and how long they would stay cold. We got the wrong ice packs, so you have to pop it and then they'll cool, and if you don't pop it, they don't cool as well. So the popped ones would get colder once you froze them, and obviously, I mean, you're gonna freeze it, so it's gonna get cold no matter what.
However, though, the idea was you don't have to use our ice packs. These are just the ice packs that we used and tested. you should be able to use any ice pack that's reasonable size, not too big, that you can put inside this product. And so yeah, we would just like to thank you all for coming and listening. Any questions?
Yeah, you said that did you test the fan one, or did you just kind of say?
We did not. That was product, so we didn't want to copy them at all and use the fans. So we didn't test any fans.
Did you test any other alternative solutions besides the gel packs?
Headband, which held the gel packs, but no, our main idea was ice packs because we didn't want to worry about any wiring or electronics because, like we said a lot, the water doesn't mix with electricity.
But what do you think would have been the most effective, fans or gels? Just kind of hypothetically.
I think the fans were a really good idea, and unfortunately we couldn't copy them, so we decided to go with the ice packs and thought it would be just a better, simpler idea than the fans.
The fans, adding on to that, the fans would have a consistent airflow for the entire game, while ice packs, they're going to take the heat in from your head, they're going to get hot and not last as long.
Okay,
So the fans
that's kind of what I'm wondering is like, because the problem with the helmet is you have to wear the helmet. So you need the solution that's going to cool you while you're wearing the helmet. Otherwise,
you can actually take it on.
Probably should.
Yeah. So it's not exactly attached to it. We should have said that.
Yeah, you can replace it.
Yes.
So like at halftime, you could.
Yes, you could take it out and replace your ice packs, or grab a new pouch like that with 3 ice packs already installed. Just grab it at halftime, throw it in the helmet, and keep going. Or if you're working outside in the heat with construction or whatnot, you can do the same thing. Go into the break room, whatever, out of the freezer, put it in there, and go back to work.
How long does the gel pack work?
The longest we had time to test was an hour and a half, and it gained 12 degrees, I believe.
This was when we tested the ice packs, and yeah, like you said, an hour. This was our control. The room was about 70-ish degrees, and the pre-popped they would shoot down to about 50 and rise up to 60. But again, you don't have to use our popped ice packs. These are just what we use at our disposal.
Quick question. How does this product differ from normally putting ice packs inside of a helmet whenever you're on the go? Like what makes this product, okay, so it just secures the ice packs in there?
Yeah, it has with the thing, and you can slide the ice packs in there, and there's snap buttons on it that snap it together and close it and keep it in there.
Can I see that part? 'Cause like, how does it not fall out when in use, let's say, on a regular?
See these straps in here?
Mm-hmm.
They have, it's a catch so that when you put it on, your head doesn't go all the way into it. So they go under that, and they'll rest on, or they'll fall and then rest on top of your head once you have the helmet on.
Okay, so it's still comfortable to wear and doesn't add any extra. Can we see it? Yeah. So they have snap buttons to keep the ice packs inside. The pouches. That's cold.
So y'all did not test it under the 150 or 105 degree heat temperatures on a football field to get a...
Yes, because unfortunately it was during the winter and fall time when temperatures would lower, and so yeah, yes, we can never test in the heat.
Summer school.
So for, this is to help keep you cool, but is there an issue with cooling your head too much, putting ice packs on, and other safety concerns there?
That is true. That's why we have it in pouches for now. But if we were to able to get more products and materials, we would get a better kind of pouch. Because these are just regular mesh pouches you can buy on Amazon. We would want to get better pouches to actually hold the ice packs. And insulate it more, but not too much to where there's not enough cooling happening.
Adding on to that, like we said, it's not attached to the inside of the helmet, so you can slide it in and out if you get too cold. It takes 10 seconds to put in and take out.
Did y'all do any research on what temperatures are too cold or not cold?
No, sir.
Is there any impact on the people with shaved heads versus not?
That was amazing.
There would be a little more insulation with how much hair you have.
Okay.
But I don't think it would affect that. I don't think it would affect it too much.
Oh, one last quick question. How did you get the bags to stay together? Like, how did you go into that? Like, how did you construct it from the stuff you got?
We actually learned how to sew this year to do it. Me and Wagner worked a lot on the sewing. Zach came up with that final design there with the 3 pouches connected to one. And again, we sewed them all together.
About 3 weeks of sewing.
Yes.
I was wondering how your straps connected inside the helmet. Is that typical helmet design where they have those little buttons where they're?
I believe so, yes.
Okay. That's pretty standard.
Yes.
So with the ice pack, how much weight would that add onto the helmet?
Each ice pack was probably a pound, maybe 1.5. So it would add a couple more to you, but I think in the grand scheme, when you're already wearing a helmet and wearing a football helmet, if you were to wear it, then the cooling effect would help a lot more, and you would worry more about the neck pains. But that is what we talked about, is we do want it lighter so that you don't have those issues when it comes to wearing it.
Anything else?
Okay guys, next we're gonna have about a 15-minute break. If you need to go to the restroom, get some snacks, drinks, anything like that. There's coffee, water, tea, help yourself, please. Alright gentlemen, our second part, we have 2 more presentations and then we'll break for lunch. Thank you all for being so understanding and such a great audience, as well as judging panel. So gentlemen, I will let you introduce yourself and get started.
You y'all's marks?
Yeah. Yes, you all stand on the tank, guys. Hi, my name is Connor.
My name is Barrett.
I'm Rodrigo. And this is our design, the Autoflow.
This isn't the actual slide, by the way.
Oh.
Sorry, by the way.
I did not do that. That was not their fault. Thank you.
Okay, so the idea for this design came from really early in the year when we were having to choose our designs. I made this really cool 3D model, and I was going to bring it to school because I brought it to school a couple times. And I thought, I can just leave it in the car. And around lunch, I can just grab it and show it to people. Well, whenever I left it in the car for like 3 hours max, the whole neck of the design just bent over in the heat. That's not like wax or anything. That's like PLA. So that it had to go over like 140 degrees in that car for that to even slightly warp. So this got me thinking about my design, or about a design that could cool a car down. And we did a little bit more research, and we found that it doesn't just cause damage to 3D printed randomness, it also causes damage to electronics and even like young children that are left in the car when parents go out and go get something. Around 40 deaths a year are caused from overheating in the car since 1998.
Well, what we're trying to go for is not to solve this problem or to be like a replacement for this problem. It's supposed to say like, this is an issue that people have and has been happening since 1998, as shown here. And we'd like something that at least can prevent the burning of electronics or can maybe prevent these deaths from ever occurring.
So we were doing some research on some patents around this design because people had similar ideas for this. This was one of the first patents we came across, and it's probably one of the ones that we based most of our design off of. It's a solar-powered fan that sits on the edge of a windowsill, and it sucks in air through this little nodule right here, The main reason why we didn't like this design is because of that very reason. All of the airflow that's going into the car is through this little through this little gap. So there's a lot less air that can be pushed into the car.
This is a solar-powered one that we found off Amazon, which actually ended up being a pretty similar design to what we were looking for. However, this one ended up having a lot of issues with its design, where this one said that it would cool the car down and make it so it's a cool temperature when you get inside. And it's supposed to filter stuff outside of the car to prevent from stuff being stuck inside the car. What we found with issues on this one was that it wasn't very practical. A lot of the Amazon reviews said that wasn't very effective in what it was trying to say that it could do. It was more expensive than what we're going for, and it doesn't really change the air temperature all that much, which we wanted to prevent.
The major issues with this design is partially because the fans are really small, also because this entire area right here is just a container. So all the air that's getting pulled out or pushed in is just getting stuck in this area and having to be pushed out in this tiny little area.
Here's our decision matrix. This was supposed to say everything that we're trying to see. We're trying to decide between a bunch of different designs, and this is what we ended up using to decide on the design. We had the fan circuit that we decided over having just the window cracked, and then we had the rubber sides that we're going to add on afterward to prevent any security issues. Then we also have the PLA case, which was this one. We might end up doing this different case for the final one in case it gets too hot, but right now we're using PLA for at least our prototype. And then we also had, between the different types of chargers, we end up going with the 9-volt replaceable charger over anything else, just due to the cost. We wanted to do the solar cells, however, it ended up being really expensive and would raise the price from this one being about $20, $30 to like $40, $50. Which was a huge price gap that we didn't want to do. Anything else? Okay. Here's our specifications by priority. This is what we wanted our design to accomplish on. We would need to prevent a raise in temperature. We need to be fit and reasonably weighted so that it could fit on the window seal, and most window seals would work. It also must cool the temperatures down below the 150 that you might see in the car whenever you enter it in the summers. It must fit on multiple car windows so that it can be convenient and be reused for different cars. It must survive in the hot environments, which I've tested a few times within just leaving in cars and stuff. The exposed parts of the product should be non-toxic, like the PLA, because this is just going to be left in the car, especially if there's going to be kids in the car, then we don't want them to be exposed to any toxic particles. Also, it must survive around at least 2 years of use, just because we want our product to be reusable and make sure it's not just a temporary product you have to throw away after 2 or 3 tries. Next, it should remain useful until this issue of child safety and stuff and cars being too hot ends up being completed in the future eventually with maybe introduction of electric cars or just some other future invention that we haven't thought of yet. And then finally, the device should not require routine maintenance. And we should be able to just put it in and leave it there for months, years, without having to constantly have people coming back and forth, minus the fact of needing to replace batteries. Tested survey. This is a Google sheet that we asked a bunch of people, asking about what they thought would be important. It's mostly just what our specifications were, like would you like the car to be cooler within 5 degrees of the outside temperature whenever you head in? Does it bother you that sometimes when you enter your car it can be up to 140 degrees? And other questions like that. Should equipment in your car require routine maintenance? Really just all the questions. And overall, they generally agreed with what we were trying to aim for.
So, how we made this prototype, the first idea, we built the prototype. It was like 2 times bigger, and it was made of wood. We went for this design exactly, but instead of this being mounted on here, it was mounted sideways. So then it'd be, instead of like this, it'd be like this. But the final design, decided to make it in with 3D filament. And then the second step was to make the wiring, we had to use those are 2 batteries?
Yes, 2 batteries. So the only thing different on that diagram is that we increased the voltage on it since we use different fans. It's now 20 volts.
Right. And then the third step of the original prototype, we had to add screws on it because it was originally going to be, or it will be, it's going to be open. It can be open and closed, so you can exchange the batteries if and when it runs out of power.
Current prototype is using a bunch of glue and different adhesives to keep everything together, which you will have to eventually use on the final prototype or some mold. Also, the fact that we want to have it openable so that you can replace the batteries without leaving the batteries on the outside of the machines.
Okay, so this is our first prototype. If y'all were at we did like an engineering presentation a couple months ago, and if y'all were there, I think Mr. Rhodes might have been there. We had this design. This design wasn't the best. Remember those two patents that I was saying was really bad because it only put in a lot of air? We were finding out this issue with this design. It had, rather than, like Rodrigo said, it had a small fan right here, right there, and right there. And whenever it was put on the window, it would just push in air and not really take any air out or add any, or like blow in any actual air.
It really failed to circulate
Also,
air.
we used our own like 3D designed fans, and they weren't really effective, especially that small size, and they kept on falling off. So we realized that our fans weren't going to be effective, and a lot stronger, more reliable fans are going to be needed. So,
and then our current prototype.
So here's our current prototype. We're using 2 PC motors, or 2 PC fans.
That's what's
They're really, really good at circulating air and are insanely quiet. I don't even think you can hear them now. It also uses a drill battery that's 20 volts and it's rechargeable, so you can just take it out and charge it. In fact, these batteries can be charged without actively removing it, so it's a benefit. If y'all saw me leave earlier, that's because I had to replace the battery, because we haven't replaced it in 2 months, and we've run that thing continuously for like 2 days straight. We thought, the battery's not going to die. So the battery doesn't have to be charged for very long in order for it to be the battery doesn't have to be recharged very often for it to be effective. We also tried it in our car. Like during lunch, I put it on the car, roll up all the windows except the one that had that. It was just chilling in the car, and it's actually relatively cool. So it works pretty decently.
And that's it.
Solar powered, does it have to go on the window, or could you, since it's battery operated, just set it on the console?
It could theoretically go in a console, but we want it to have access to open air. So one of the main reasons why is because the car as it traps in air, it's acting like it's just heating up the air inside and making it really, really hot. So if we can push in new air, it helps it circulate a lot faster.
Yeah, the goal of it is to circulate air. And if you don't put it in the window, you just put it in the car, it'll just be a fan, which is not exactly what our goal is. We're trying to
increase security of your car being locked in the way that's attached and the gap that it creates on the window?
Yes, that is a primary concern.
That is a primary concern. We have a couple ideas on how to exactly get about that. There is different brands that have ended up using rubber ceilings in it, which is really dependent on how far a final product would end up having the gap between the car and the window, which could be solved by a rubber casing on it, or it could be solved by having it a specific 3-part set to each car, which then would decrease the ability for that being used on certain cars. It's not a 100% confirmed thing for that yet, but that's kind of what we're leaning towards.
Did you run any temperature tests using it with or without the device? And then with the window being open that far,
we use a similar
the window being open?
We use a similar temperature sensor that Wagner's group used, but it was meant for fish and stuff, so we couldn't really guarantee the accuracy of it. However, it was a lot it was significantly higher. It's around 135 whenever I put it in there beforehand, and then after like 10 minutes of us just like chilling in the car, I think it leveled out around 95. So that's a lot, significantly cooler, and it's circulating air, so you're not going to get really, really badly hurt if you stay in the car for a long time with that in it.
Did you run a test with the window open that much without the fan in the car? How much is just from the window being open that the heat's leaving the car versus the fan?
We did not run a test on that. However, there was a significant amount of air blowing, so there was a significant effect on that.
I didn't quite catch it, but do you plan to seal the opening other than where the fan is?
Actually, we do intend to plan it. One of the main ways that we saw was, or one of the best ways we saw that people solved this issue was on that black design. Basically, it came with this like rubber flat that you could just cut to the shape of your window. Obviously, we can't do that because we don't have access to that amount of rubber and that specific type of rubber, but that is a pretty easy way to solve this issue.
That's kind of the plan of what we're going to go with.
And did you test, or did you think about like whether the fans, is it better to have the fans pointed like that, bringing air together in like that, or is it better to just have them flat to the
we just did this because it's a lot narrower than if we just had it flat.
Any other questions? What about safety? What's stopping like a little kid from sticking the finger between the fans?
These fans aren't really strong. Hey.
They're not very strong. They are made from used everywhere.
Yeah, PC fans aren't really dangerous fans. You might get hurt. You might hurt for a second, but it's not going to cause like any major cuts or bruises or anything like that.
Hopefully any child that will be in the car won't be able to reach high enough to reach the fan, and those who would, it's not going to hurt them.
Yeah, it's not really that bad of a injury if you do it. Just like getting whacked by a fan or getting whacked by a piece of plastic.
But really, you shouldn't be leaving that and a kid in the car at the same time.
You shouldn't be leaving a kid in the car in the first place.
Yeah, just don't leave your kid in your car ever.
This is the whole point of that, to make sure that the car is cool. So if you accidentally do leave your kid in the car, they're not gonna go. They're not gonna.
It's not an accidental if you do, like, don't leave your kids in the car. This is more of something that'll have a different effect. But hopefully, if that does happen, which we don't want to happen, it will be able to maybe prevent more heat-related injuries. I mean, they would have heat-related injuries even in 100-degree cars. But hopefully, with this end of the window, it'll first cool off the car and prevent like any damage to electronics or anything. But even if there is a kid in the car, it should.
And plus, afterwards, if you leave this on the side of the car, it's going to be a lot cooler. So you're not going to get third-degree burns by touching the buckle of a seatbelt.
Yeah.
Have you guys thought about making it more like a permanent solution? Something that can like connect to the car battery, let's say?
The problem with that is the only way to access the static power from the car, other than like physically wiring to the car battery, which isn't the smartest thing to do in the world, is through a cigarette lighter, which is always on because it's connected to the power. But a lot of newer cars are not coming with cigarette lighters. So we can't access that whenever the car's power is off, or whenever you unlock the car, it disconnects all the power except that.
Yeah, it's really like we didn't want to have to like directly work with cars and make this more of a consumer product that wouldn't be necessary to have with cars, and people could just buy it on top of the car and be easy to set up.
Any other questions?
Just moral of the story: don't leave your kids in the car.
Yeah.
Hi, my name is Cameron Schultz, and this is the 3D filament recycler. This is a product that I have innovated in order to solve the issue of PET bottles permanently accumulating at our landfills and in the environment. In case you aren't aware, these are PET bottles. This is a 2-liter variety. They come in gallon all the way to small water bottles. This machine is capable of stripping all of those, even though it is more efficient at stripping the 2 liters. When you get to the larger ones, it does have some problems. So over 40 million tons of plastic waste was generated in the US in 2021, and only 5% or 6%, or about 2 million tons, was recycled properly. Others ended up in the environment or just thrown away in trash and landfills where they will not disintegrate because PET plastic takes a very, very, very long time to disintegrate into the environment. It's simply not profitable on a large economic scale to implement the classic recycling model. As here in Texas especially, we don't have a return system on 2-liter bottles. You take it to a recycling center, as I have often done in Bellville before inventing this machine. You just take it in and you just recycle it for free on your own accord. You know, of course using your own gas money in order to do so. My product aims to solve the issue of that problem. So some current and past methods of reducing plastic waste. The first mainstream recycling push was done in 1916 due to the massive shortage of raw materials. It was originally done in order to serve World War I because they needed more cans originally for tanks and such, because a majority of consumer goods were manufactured with tin and such. 73 years later, in 1977, the first plastic bottle or PET bottle was recycled by mechanically grinding the bottles into a powder, melting them, and molding them into new bottles. This is incredibly energy intensive and not cost effective at all. The amount of energy it takes to grind the bottles already outweighs a majority of the price you can gain from selling these at selling the bulk plastic at a market price. The United States actually, for a majority of the recycling, does grind it here and then ships it off to other countries who will pay a premium for it because they don't have access to large materials that we have in the United States. But they generally sometimes even just discarded plastic PET bottles. They simply just grind them up and then throw them away, even if they are sent to recycling centers. This is because depending on plastic fluctuation prices, which fluctuates on oil prices as well, PET plastic prices change. So it is randomly profitable, randomly not profitable. So companies often don't like to set up large deals. So some more issues with the PET recycling process is the high upfront cost. It can cost anywhere upwards of $500,000 to $2 million, depending on the size of the plant to get it started. And low profitability, as I mentioned earlier, it's only about $160 per ton on average of recycled PET plastic. So in order to create an effective design to solve this issue, I needed to be cheap, safe, and effective. My design is very, very safe. There is a hot end on here that does reach about 215 degrees Celsius or 420 degrees Fahrenheit, but it has a very nice fan shroud, and it's very, very hard to stick your hand in here and actually get burned. I've burned myself on actual 3D printer nozzles. I've never burned myself installing or starting the stripping process on this device. PET plastic is also actually food safe. It is one of the only 3D printable materials that is food safe. PLA, which is the material most of this machine is made out of, is not food safe, and it will harm you negatively. And it has to be effective. It must reuse as much PET plastic as possible. The only issue with this design is the bottom cannot be stripped, and the very, very, very top right here cannot be stripped of this bottle because it will turn and not cut properly on here. So some common alternatives to PET bottle recycling is reusing. I know people have made, terrariums. You can make any sort of other thing. You can make little musical instruments. But the issue is they will degrade. They will start to smell, especially if you don't clean them properly, which the majority of people who are recycling things to do that in that nature struggle with. You can switch to biodegradable materials, but once again, they can only hold certain materials for a certain amount of time, so it's not necessarily effective. You can use reusable bottles. I know there's been a large push in recent years to hydro flasks or Stanley cups or all the like. I'm sure all of you have seen people walking around with large, ginormous bottles that are often heavy and hard to lug around just to save the planet and solve plastic issues. But that's not economically viable for everyone, and it does not solve any current plastic use. So my product design. In order to solve this issue, I've taken inspiration from an open source design made by an individual who goes by JRT 3D. Several elements of here were used on that, but I did modify nearly each and every single piece because his design was an open source, completely commercializable design that did not fit for this printer. It was for a different printer, which is actually way less commercially available. My prototype utilizes parts from an Ender 3 that the school provided me. It no longer functioned. Several of the motor drivers were shot, and I had to rewire several things for it. Ender 3s nowadays will range you about $90 to $100, or you can get them from scrap parts that no longer work for about $40 to $50. The PLA plastic parts cost about, I would say, $20 in total. This ran me about 2 spools, so about $20. So continue product design. So this portion right here is the bottle cutter. Once you remove the bottom part of the bottle, you simply thread this bottle onto here, slide it through here, and then cut a very, very, very thin, narrow strip in order to thread it through the hot nozzle. Once it is done like that, you take the pliers and you pull and thread it onto here. Once that is done, you can set it to automatically wind, and it will wind an entire spool filament for you. You can set it, forget it, it'll finish when it's done, it'll stop. This part is extruder, so it gets hot. So this material, I'll pass you around a little sample from when I cut part of this off earlier. It is actually folding the PET material. So it's pulling it at 215 degrees Celsius, which is not the melting point of this material. The melting point is about 260 degrees, which is sort of on the upper range of what 3D printers are capable of. It pulls it at 215 degrees Celsius because it is actually rolling it. It is hollow core filament, which means you have to increase the flow rate on 3D printers in order to use it properly, but it is very well documented how to print with this sort of material. Next is the stepper motor. The stepper motor is what powers this large gear here. It allows for a consistent and reliable pull. I have it geared down so it spins faster here and slower here, so it doesn't rip it out. I have the LCD screen, which is once again salvaged from an Ender. Covered that part. So some product construction things and issues I had. The stepper motor kept overheating. I was trying to print several versions of this, including this floor here. Took me about a week because every 20 minutes the thing would overheat, and it was causing me a bunch of problems. So I had to actually swap up to a larger stepper motor that was included with the printer. I initially tried putting a fan on it, which is wired directly into the board. All of the wiring itself was done by me because there are wiring diagrams of how the printer works, but for this process you have to specifically rewire it, which was not included. I couldn't find it anywhere on the internet of how to actually rewire it to this exact purpose. There's plenty of guides on how to do some wiring, so I learned how to do it that way. Another main issue I had, this took me, I don't know, almost an entire month to solve, was I kept getting heating error issues, which is where the thermistor, which is a thermal resistor, it measures temperature based on resistance, inside of the nozzle was measuring a super high temperature randomly. And I tried to disassemble it. I was going to have to essentially order an entire new hot, which would have cost nearly the exact same amount as an entire new printer because individual parts are more expensive to make and send out. The issue that I found out eventually, after just essentially almost giving up and just leaving the fan off it to see what would happen, it started working. So the issue apparently is, after weeks of finding it out, is there is a small bit of exposed wire on the thermistor, and it was coming in contact with the metal fan shroud. And this was adding resistance as it increased in temperature, so it was essentially rating a higher temperature than it was, and it wasn't allowing it to get to a higher temperature. It was drawing more and more current, and which was causing it to fail. Some testing I did in order to find out the proper pulling temperature was this. I tried to pull it at 210. It was a little too large. The proper filament diameter is 1.75 millimeters. And so I tried different filament temperatures and ended up settling on 250 degrees Celsius. There's that. 3D printable filament like this is the most common type of filament. Filament is a very large market in the United States. Upwards of about $1 million every couple months is made just on 3D printable filament because it is an expendable resource. All of this was made on filament, which is a different type than this, but it can be printed on this. It is a very large market. I know the school spends very, very large amounts of money constantly getting new filament because, I don't know, nearly every single design here was made possible with 3D printing, which we could have saved vast amounts of money on had we been able to, at that point, make our own filament. This filament is a little harder to do than PLA, but it is still quite manageable on nearly every single hobbyist 3D printer. So yeah, it is a very easy tool to use once you have a 3D printer in your own right. So thank you. This is the 3D filament recycler. It is a product that I believe can solve major issues on PET bottles and the environment, and also allow schools and municipals to recycle PET plastic at a large scale. This design can be scaled up. It had multiple in series. And I believe it's more economically viable than large filament recycling centers or normal PET recycling. Thank y'all. Okay,
so have you ran that filament back through a printer to see how it prints?
Yes, I have. I've ran it through a printer, but I haven't had actually any time to physically print something because nearly every single other person was using the school printers that I had access to at the exact moment. So I was able to get some through the printer and get a couple layers, but I wasn't able to actually physically print anything at this moment because, once again, I didn't have printer time available because it takes a while to dial in because it is a more advanced filament than PLA, which you just basically plug and go. So it's a little harder. You have to spend time on the particular machine to get the print.
Since it's hollow in the middle and it has a gap in it, how is that going to affect extrusion rates compared to filaments that are completely solid?
Right, so I mentioned this earlier. So because it is a hollow core filament, you have to increase the flow rate of the 3D printer. So the 3D printer essentially just pushes material through a smaller nozzle. You have to increase it so it pushes harder. So it essentially extrudes the same amount by pushing harder and the same amount of time.
Would that hollowness be different per different bottle you use?
No, because the way the nozzle is at point, I drilled it out to a 0.75 millimeter diameter, so it essentially pulls it to the exact same diameter every time, and the bottle cutter cuts the same, I don't know if you can see right here, same with the strip on the entire bottle, so it's incredibly uniform.
So with PLA, if you leave a spool of PLA sitting out for a couple of months, you end up, it absorbs the moisture and then you can bake it. Do you have to bake this filament before you can use it?
It depends on how long you've left it sitting out. So if you left it sitting out for a very, very, very long time, it can absorb a small amount of water. But once again, these materials are meant to hold water, and they're meant to hold these types of things. So it's a lot harder to get it to absorb water, but it still will after a very, very, very long amount of time.
I don't know if you mentioned this, but is there any structural differences between that filament and just regular?
Yeah, so one advantage of PET, which is nearly the exact same material as PETG, which is a really common engineering filament, and it's a very, very high temperature. PLA is printed at a lower temperature than this. This is printed at 260 degrees Celsius. So it is a higher temperature resistance, and it has slightly larger impact resistance than PLA. PLA shatters easier than this material.
How do you remove the bottom of the plastic bottle to put it onto this machine? And how could you make sure that the average lazy consumer is, willing to cut off the bottom of each bottle to put it onto there to make it?
So it's actually a relatively quick process. I did it when I arrived here this morning. You just take a pair of scissors and snip off a corner and then go around and strip the bottom. You just cut a little circle on the bottom, cut a little ribbon as I illustrate here. You cut a little ribbon and you shove it through the nozzle and then you pull it through a little bit. It takes about maybe 5-10 minutes to set up on your own. It's not super labor intensive, especially when you're allowed to just set it and leave it once you're done.
How long does it usually take per bottle?
It can take, depending on the bottle, some bottles are thicker than others, so it will take a varying amount of time. I've noticed it takes about 40 minutes to strip an entire bottle to get a spool of filament.
Do you get off of a 2-liter bottle?
I haven't measured a full amount because sometimes it just depends on how much I'm able to cut on the bottom or how willing the bottle color is to go up here. It will vary in length, but it's about, so a normal spool of filament's 2 kilograms. It's about maybe a quarter of that per bottle.
What about I guess what I can see where you have a lot of small schools, because is there a way to join them together, or?
So this is a common PLA practice, is when you have small amounts of filament left, you get a filament joiner. We have a filament joiner at the high school actually, but it will not go up to the required temperatures to join this type of filament. So you can make your own custom one or swap out. Normally modern printers are equipped with filament run out sensors, so once the filament has run out, you're able to just replace it with a new roll of filament. So yes, you can, but it's just a lot harder to do than other materials.
So what's stopping you from just grabbing a wire and just doing it yourself?
Well, because
I understand, like, is the temperature like that big of a thing to do?
Yes, so it has to be a very specific diameter, and it has to be a very specific shape for it to actually go through the nozzle. 3D printers are notoriously very, very picky. They like to clog and they like to jam. If it's not exactly perfect, sometimes it has issues.
Okay. Building off of Drew's question, so you about the lazy consumer not really wanting to cut off the bottom of the PET ball to actually start the filament creating process. Right. Are there any other products that are similar to yours, or like the ones that you've innovated from, that actually do that for you and that kind of automate it completely for efficiency's sake?
Actually, I haven't seen anything commercially available right now to take the bottom off, because it's such a weirdly unique thing you're going to have to do to snip them and get a circle off. I suppose you could strap a razor blade to something and do it your own self, but it's quite a weird thing to automate because of the way different bottles are, shaped. It's hard to get the exact same for everything.
I love that you leveraged like an open source project for this. Could you talk about what were the innovations that you made on top of the project?
So the project had very, very, very limited information on it. There was just it's a couple things online that I've seen from it, but I had to resize pretty much everything to fit with this printer. I've had to figure out pretty much how to do all the wiring. I rewired and redid the spool mount, and pretty much everything has been innovated. The bottle cutter is one of the only things that I had not changed completely on my own, because it's a very, very, very efficient cutter, and it's very hard to find any other solution to get something be the exact same size at all points using materials that come with the printer, because these ball bearings that you see right here to strip the actual thing. Here, I'm gonna bring this over yet. That you see to strip the actual thing came off the printer. So essentially, I got an angle grinder and drilled a screw through it, held it on there, and sharpened them, so it will cut the thing the whole time. Ball bearings, right? To strip the bottle.
That's interesting. I thought it was a blade.
Right.
So you mentioned
the blades have safety issues, which I was very, very concerned about.
Says they gotta die.
And you mentioned it automatically shuts off when it's done.
Yes.
How does it know?
So there's actually a timer, so it'll shut off after a certain amount of time. You can come back, and if it's still a little bit left, but the timer is quite a bit underneath, so it will shut off. I could also, in future iterations, put filament run-out sensor. Those are just a little bit out of the price range. Didn't have access to one at the moment.
So the ball bearings are just offset on top of each other?
Right, so they're offset, and they're sharpened at the top right here, and then the bottom is, this part is not sharp, so you won't cut yourself on this one.
Okay.
So you thread it through and then pull, and it's just cutting a thin little ridge right here. And it's the uniform diameter.
You can make run-out sensor.
Mm-hmm. Run-out sensors are very, very cheap on that. I just didn't have access to one on the printer that I pulled most of these materials from.
You mentioned that you could scale this up.
Right.
Do you have any ideas how you could do that?
Yes. So many of these nozzles can just be used because these are just commercially available. You can set them all together in series, so more machines can run at the same time. So you just buy another one and buy another one. Also, essentially have two running at once to just strip on one unit. So essentially this could just be a pack of one, let's say, and one of these could control 4 different things, because there's actually 4 different slots for motor driver slots on the board.
Can you speed it up?
You can speed it up, but the issue with speeding it up comes with a potential rip. I've tried faster speed, I didn't include that graph on there because it was a little sketchy, but I've tried different speeds, and with randomly sometimes pull it too fast and snap the filament because it's, of course, hot.
So I've seen similar designs where they droop the filament, and there's like some sort of height detector so that you can get a consistent diameter. What What made you choose this style of design?
So what made me choose this style of design is it's a small form factor and it's quite easy for me to produce. I had to learn a lot of wiring and electronic stuff to do this, obviously. So this was a little easier to work with. And it's just a lot more simple for the average person to load and do.
Yeah, cool.
So each of these other components you 3D print all of that?
Right, I 3D printed every single one of these components over a long course of time. Of course, dealing with other people having to print other things and other school activities using this stuff.
So Cameron, could you use that filament to make bottles, and then once you do that, if you can, could you just recycle it, keep doing that, or would the structure eventually of the bottle be really bad? You would have to
sit
throw
this
it
down
out?
and answer you. So I don't think that would actually work quite well. So the reason this works so well is usually these bottles are shaped and done in a pretty normal specific way. And the the thickness of the plastic is pretty uniform. When you're 3D printing, it's additive manufacturing, so there's very little waste, but it leaves layers. And so it would essentially just break up the layers, and so I don't think you could run it by again. One solution could be to, do what actual manufacturers do after you're done and, make it into pellets and then extrude it that way, but this machine isn't capable of that quite yet.
Would that be a good modification in the future?
Yeah, that would be an interesting modification to work with using, ground up filament pellets, but I don't know how to do that.
Potentially allow you to recycle other filaments as well, such as PLA.
Yeah, that could be, done to other things, because this machine can operate in a wide variety of temperatures. So if in the future this product was able to implement a different type of method to pull, shredded filament through, that would be an option. Yeah. Any other questions?
So what's the price point for that device?
So as retail, you could probably run this at about $300. The money would quickly be gained back, with filament costs, because filament spools essentially cost $20 for a basic normal spool PLA, PETG, which is this material, but the glycol flow modifier, so it flows through the nozzle just a bit easier and sticks to beds just a bit easier, will run you about $30 per spool. So this will quickly make up the cost of material and labor. Any other questions?
So it seems like you would kind of be limited by color. Would that be a big factor? Green, clear.
Yeah, so green in bottles and clear bottles are kind of the norm. What I've seen, I don't know how easy this would be to do, but you can mark on them with Sharpie, add a little Sharpie right here, and that will stay through the filament and it will go through the outside, but it's not exactly uniform, so that's why I haven't added it on this exact thing, because it's not super precise as of yet from what I've seen. One thing I forgot to mention earlier actually was these green bottles are not accepted at the local Bellville recycling center that I've been to, because I recycle all of my things. I recycle cardboard boxes and bottles before I made this. These green bottles, they tell you to throw them away. So this is essentially the only, at least locally, solution that I've seen to do with these bottles, other than, have them end up in a landfill. Any other questions?
When will we see stuff 3D printed with this plastic for sale out there?
Right? Pretty soon, actually. I mean, I have quite a number of spools. I'm just waiting for some, projects obviously to calm down. So actually, the next couple of weeks, I'm going to be trying to print some stuff with it at the high school.
Better see a green benchy tonight.
Yeah, that's like a green benchy.
Yeah, that's what I was going to print first, actually. But yeah. Any other questions? Okay, well, thank y'all for having me. It's been a great time listening to all of our products, and thank you guys for joining us. Greg, you want to help me back some of those?
So we have actually talked with student council, and they're talking about recycling water bottles as well at the high school. So for future continuous recycling going on. So thank you, Cameron. Thank you guys very much. That was our last presentation. So I know the judges may have a little bit of tallying to do for that side, and then I will as well. Our visitors, you are welcome to have a break we're gonna come back at 12:30 and I'll just be announcing the winner, first, second, and third place. So you're welcome to come back for that announcement, but it's not going to be, and we also have incentives. Some of our lovely guest judges have also provided some donations. So at the award ceremony at the high school, I'll be presenting those actual dollar amounts to the students who have won. Because depending on if it was 3 in a group or 2 in a group, those separation of the funds needs to be adjusted slightly. So that will happen at the award assembly. But today I will announce first, second, and third at 12:30 after we finish all of the tallying of the results. So you are welcome to take a break for lunch and come back. But thank you so much for showing up for us today. So I want to go. All right, guys. So welcome back from lunch. Hopefully you guys had an enjoyable conversation with the professionals and vice versa. I did want to speak to our donors who have actually given us our prizes, which will be divvied out at the awards ceremony. But today we do have certificates, and I appreciate you guys so much. And we had a little goodie bag. Gentlemen, would you pass this out to our judges? Just thank you so much for all the time and effort and all the contributions that you guys made. We gotta give you some Bellville swag, right? Okay, so drum roll? No drum roll. So starting with third place, we have the charge lit by Kyle Middleton and Sam Bradshaw. I'll hand you this and then shake your hand. Thank you very much. Good job. All right, you ready? Thanks, guys. Good job. Good job. All right, and second place for the Trek Tech TS, Drew Merrill and Alex Juarez.
Foot down.
Good job, guys.
Thank you.
All right, and first place with our 3D filament recycler, Cameron Schultz. Thank you. Thank you guys very much. You're welcome to stay. I would ask, they wanted 3 of you guys to stay and do a quick interview. So I know, Drew, you had to go. Alex, Kyle, and Cameron, I would like for you guys to stay and be interviewed, and then we'll go from there, okay? It won't be too long, but thank you very much.
Like 3.
Yeah, you'll be okay. Everyone else, can you start gathering things up and getting it presentable, and we'll go from there. Thank you guys very much. I appreciate it.
All we need.